All right, I think we're recording now. So anyway, what I was saying, today's going to be all about proofs, and I know we're struggling, so we're going to do some examples, very, very guided. And when we get to the part where we're going over questions from the Mastery Connect Bank, we're going to talk about strategies and patterns that you see among those answers and the question styles to kind of help you navigate tomorrow's weekly check. So the first thing we're going to do is this assignment right down here. So go ahead and open that in your Google Classroom. It's triangle congruence. It's right below today's post. While you're getting there, I want to point out a note that's above it. I'm changing the Ixl requirements for this pair of Ixls only the ones we've been working on this week. Instead of getting to a 90, you really only need to get to about a 75 on this one for full credit. So if you get a 75, it's going to be a 100 is what's going to get recorded. 75 out of 75. Probably 7.5 out of 7.5 if I'm being real particular, but that's only for these two. Not for any after this, not for any before this, just for the ones on proofs that are due tomorrow. And some of you probably already have it up to a 75. So we'll work on those at the end of class. So, oh, this is not what I need. I need to open my version of it. Okay, so when you open that assignment, let me undo all the answers from last time. Oops. Okay. When you open it, you should have a blue and a green and a red slide. And we're going to start on the blue. I'm going to kind of toggle back and forth between present mode and this working mode because I can't drag my points around in the presenter mode. So what I want you to notice and what we're going to practice is you don't have to do everything on the proof all at one time. You don't need to make it overwhelming by giving yourself too much information to go on. Okay, do the easy parts first and then break the other parts down into smaller, more manageable chunks. So for example, I've got the first line filled out for me. AB is congruent to CD and that's given. And then we've got BC is congruent to AD. Well, that's up here in the top as well by this word given. So what reason is going to go there? Given. There you go. Ta-da. Given. This is where I have to toggle back and forth. So if we're going to put given right there, let's just go ahead and get all the easy ones first. On line 4, I'm proving that two triangles are congruent. To prove that two triangles are congruent, I have to do some of those patterns with S's and A's. What's the only one over here that does that? Yeah, so that's got to go there. So let's pull SSS right over there. Okay, this is in your Google Classroom and I'm working it with you and then we're going to submit it at the end so everybody should get a 100. So yes, we're doing the answers like together. Yes, ma'am. I don't have mine here. I'm sorry. Is it still not connected? Try like jotting down the answers. And then maybe when you get home or when they fix your iPad, you can go back in and enter them. All right, so after we've got two triangles congruent, then we continue to talk about their smaller parts. After you have said that the triangles are congruent, and then you continue to talk about their parts, what reason is that going to be from this column over here? After we talk about triangles being congruent, and then we continue to talk about their corresponding parts being congruent. Hint, hint, hint. Which one of these is that going to be? Very good. So corresponding parts of congruent triangles are congruent because we said the triangles are congruent and now we've got corresponding parts and we're saying they're congruent as well. So that's got to be this. So look, you've only got one pair left. And so let's look at what needs to be a statement and what needs to be a reason. All of your reasons need to be general terms that you could put on lots of different proofs. Your statements need to be specific things that apply to like this shape up here at the top. So which one's going to be our statement? And so then our reason must be reflexive property. And that makes sense because AC and AC, it's the same thing on both sides of the congruent symbol. So that's what reflexive property is. Okay. So any questions on that before we move on to the red slide? Okay. I think I skipped one. There it is. All right, so on the red slide, you've got a little bit less. The proof's a little bit longer and a little more to fill in. But you don't have all your givens listed, so you can start with that. We know what reflexive property ought to look like, so we can put that in there. I'm going to give you a minute to try to put those where they go, and then we'll just check them. So our other given, I'm going to go ahead and put given right there on line 2, says that AC is perpendicular to BD. They've got it backwards. I don't really like that, but that's the one that they're using. It really ought to match this perfectly, but that's okay. So reflexive property should be which of these ones that's left. Same thing on both sides. Yeah, BD is congruent to BD. That's the one that has exactly the same thing on both sides of the equals. So we're going to put that on statement 5. And then let's look at some other kind of easy stuff. On line 7, we have, I'm not going to be able to hover over it because this little black bar is going to be up. On line 7, for the reason, we have CPCTC. That can only be used after we have proven that some triangles are congruent. So I'm going to go find the triangle congruence statement. Triangle this is congruent to triangle this. That's the triangle congruence statement. And that's going to go down here. And then I'm going to look for a reason that we can say triangles are congruent. That's going to be one of those patterns with sides and angles. I've only got one, so it must be side, angle, side. So then we've got angle ADB and CDB are right angles. Right angle congruence theorem. Angle ADB is congruent to angle CDB, and definition of perpendicular lines. Let's keep in mind that we can only work with what has already come before. That's why we have to start with a given, because that is what was told to us to get us started. So we've said that these lines are congruent, AD and CD, and then we've said that AC is perpendicular to BD. Which of these two facts is the best one to come after perpendicular? That they're congruent or that they're right angles? Right angles, yeah. Perpendicular lines make right angles. They don't, by definition, make congruent angles. They just make perpendicular angles, right angles. So right angles comes from the definition of perpendicular. We said that's what perpendicular means, right angles. And so that's where that goes. So that leaves these two, leaves us saying that the angles are congruent because all right angles are congruent. That's what the triangle congruence, right angle congruence theorem says. And so then if we kind of look through here, you've got the triangle congruence pattern, which normally you would try to sketch out, and you can go back through and see how that lays out. We didn't need it in this particular one because you only had one pattern that could match up. Yes, ma'am. Of the red or the blue? Try clicking undo a few times. Or which one of these? Maybe it's underneath, maybe the first given had something on top of it, something like that. Is it just the one piece? Is it just the one piece? Okay. If it's just the one piece, just let it go. I'll remember that that was you. Okay. So on proofs, this next one is blank, right? The green one. I'm going to leave this up, make sure everybody's got it filled in. The green one is blank. I want you to go ahead and try to fill in as much of it as you can. Remember to start with what's easy. Givens are easy, and where you're trying to go, what you're trying to prove, that should be kind of easy too. So I'm going to give you a minute to fill those in on your own, and then we'll start putting them on the screen together. Are you still using the red, or can I move it on to green? All right, let's talk about how we could start with this one. What are some of the things that you put first? Mm-hmm. And that's going to be, I'm just going to put it on line 1. And what reason goes with that? Yep. What else? Mm-hmm. Very good. And what reason goes with that? Given. Mm-hmm. And then the next one. Very good. What else did we put? Okay. And how do you know A and D are right angles? Yes. Did anybody skip down and do number 7 after you did all the givens? That's what I think I would have done. What should go on line 7? Good. Because that's what you're trying to prove, right? That should be your last statement. And then we're trying to give a triangle congruence postulate over here. So which one's that going to be? Yep. So now we've just got a couple of things there in the middle. So we have said that angles A and D are right angles. What else? And honestly, after you've put this in here, the order doesn't really matter on these next 2 or 3. It is, very good. So there's that and that. So that means that this other pair, this must be our last line. Triangles ABC and DCB are right triangles. That talks about specific stuff from this shape. So that's a statement, and then definition of is a reason. Now, in a proof, you could have certain things going in different orders because it's not really like a math problem, like an algebraic problem where you would have to follow order of operations. You're just making logical connections based on valid reasons. And so certain things do have to happen before certain other things, but there are other parts that you can kind of mix up. So for example, as long as you say that A and D are right angles, before you say that these are right triangles, it doesn't matter if you put CB and CB in the middle or up here on line 4 or down here on line 6. As long as A and D are right angles comes before the statement about being right triangles, then it's fine. Technically speaking, you don't have to put 2 and 3 as these givens. You could put these other givens anywhere else as long as whatever you say after AB is congruent to DC makes sense with only that information. It's just a good idea to go ahead and put all of your givens at the top, but it's not always necessary. So any questions about any of these three proofs? Okay, so then what we're going to do next is we're going to do a little Kahoot. Folks at home, I'll post your Kahoot code so that you can see it. We'll do the Kahoot. Yes, yeah, you can go ahead and submit. Sorry. So folks at home, I'm going to post your Kahoot code later for whoever would like to study for that. And then we'll be back.